Thank you for joining me for another demo on Jenna's Runbooks. In this video, I'm going to demo the creation of new Azure Active Directory users by referencing a CSV file populated with user data. These users will be assigned certain departments. The department names will be used as group names. One of the department names will be used to dynamically assign user membership by looping through a list of users. The other group will use the Azure Premium license functionality of type using dynamic membership to assign users. For the duration of the demo, I'll be remaining in Visual Studio Code and the terminal. However, if you're interested in exploring the Azure portal, I recommend checking out my previous runbook on this topic and the demo with that from the series, which goes into depth on the functionality of Azure Active Directory, role-based access control, conditional access policies, including multi-factor authentication, as well as validating access by performing some test scenarios of logging in as newly created users. The topics that we'll be covering in this runbook include GitHub Actions service principal names being created and their permissions and configurations done using Terraform. In my previous runbook on this series, I created the GitHub Actions SPN using AZCLI, and then I set the permissions using the Azure portal. However, in this runbook, I'll be showing how you can do it all via Terraform. Additionally, we'll be further locking down the GitHub Actions SPN by reducing the privileges from subscription owner down to specific API reader level permissions. We'll be going over the Azure Active Directory users managed by Terraform with a for each meta argument using data populated into a CSV file, as well as Azure AD Group members assigned using Terraform for each meta arguments as well against users assigned to specific departments. In the next section here, you want to prepare your prerequisites in order to follow along in the lab if you'd like. I linked to the previous runbook here because these are all essentially the same things unless you don't want to purchase the Azure AD Premium P1 or P2 license. If that's the case, you'll have to remove any references to the conditional access policies, multi-factor authentication, as well as the dynamic group types set in the Azure AD Group Terraform resource. You'll also need to, just like in the previous runbook, ensure that the security defaults are disabled in order to create conditional access policies. And then this last point here is, although it's not required, if you're interested in how I got the highlighted changes in my GitHub Actions bot PR comments, I did write up a runbook on how to do so linked here. And I'll show you what I mean real quick. We'll be going over this. This is my pull request for this demo. And all these are hidden because I was doing testing and they're no longer relevant, but we'll be focusing on this last one here. And the colored highlights I'm referring to include these, as well as if it's redacting any data or resources, it would be red, but we're just going to be purely adding resources in this demo today. So those are all of the prerequisites. Here are the design artifacts. I'll be linking this YouTube video here. You'll want to clone the repository containing all of the Terraform artifacts linked here. The particular directory we'll be working with is the Azure AD Users Group's roles part 2. So the previous runbook did not, it was just like this, no part 2. And then if you want to configure the GitHub Actions service principal, as well as a storage account and blob container for hosting the backend state files, you'll want to grab the Azure Dev Infra directory and modify that to your infrastructure settings. So the first step in the procedure is always to authenticate to Azure and configure your local environment variables, or however you like to set up your communication with your Azure infrastructure. So this is just like a simple way of doing that. I use Windows Subsystem for Linux. So just AZ login, grab your subscription ID and set it to that. And then if you are storing your state files remotely, you'll want to have your access key to do that, to be able to allow that. And then I also threw in a command here. If you're working with multiple subscriptions, like in an enterprise, this is a good way to list out all of your subscription IDs and their names to grab the particular ID that you need, that you'll be working with for this lab. The next step is to create the GitHub Actions Runbooks AD SPN. And I've already done this because it's required for the remainder of the lab, which is why I set it in that Azure Dev Infra directory, since it's kind of outside the rest of the infrastructure and it relies on this to work. So I'll go ahead and show you the config quick here in my VS Code, which is under Azure Dev Infra in the apps.tf file here. And you can see the resource right here for the Azure AD application. And this is pretty much pulled from the HashiCorp documents for Azure Terraform. And everything is basically the same except for where it said example, I just replaced with GitHub Actions. And then for the ID, I didn't have a requirement for this UID, so I just use this random UID generator. The rest is all pretty much what they had, and I removed some stanzas that I didn't require. And then we get into these are the actual API permissions here. So where it says required resource access, we have our resource access settings. These are the API permissions that we saw in my previous runbook where I set these in the UI of the portal. These are all read-only privileges that are needed for this particular lab. So instead of having, subscription owner where it's like able to have, high-level privileges for everything, we can just set it as, actually we have it as a reader across the entire subscription. So we have it allowed to read across any resource in the subscription. And then we also have it allowed to read, Azure AD Users, Azure AD Groups, and the Azure AD domain for this particular lab. And then these are the same permissions that it had from the previous lab, and these are what allows it to work with the conditional access policies and the particular settings that we configured within there. And the rest is just pretty much standard of what HashiCorp had. And then we've got our Azure AD Service Principal resource. Because when you create your Azure Service Principal outside of the portal, you have to create the Service Principal within your code, whether it's like the API or CLI or like this in Terraform. You have to create the service principal, and you also have to create the application, so the app registration. Whereas if you created this within the portal, it would automatically create the service principal for you within the one. It would create the app registration, and then it would automatically create the service principal, which gets loaded in the enterprise applications list in the portal. So this is the setup for the GitHub Actions SPN. Now I have this set up to, you'd run a Terraform apply from within this directory, and then it generates outputs in this outputs.tf file that we have set up here. And what it's going to do is going to give me the subscription ID, the tenant ID, the app ID, and then it doesn't actually output the client secret for the service principal. Because it's sensitive data, it's not going to give us the password in clear text. However, there is a command that I referenced here that will allow you to get the raw output of that secret once it's created. You can just run this and grab your secret. So that output stanza that will populate after you run your Terraform apply will give you everything you need to then move on to step 4 and set up all of your GitHub secrets. So those 4 items you'll have at that point. And so just a little note here, as I've mentioned, we've been modifying and locking down the service principals privileges. So I had assigned it the user admin Active Directory role. However, I found that was no longer required because I was able to put the specific API permissions on there for the readers. And then, like I mentioned, I was able to remove the subscription owner role and assign it the reader role and the other reader API permissions to get it to run the Terraform plan data. So the next step we're moving on to, the bulk of this lab is populating the users.csv file. So if you're importing an existing Azure AD user base into Terraform, like I was for a production environment that I'm working with, what you can do is you can navigate in the portal to Azure AD users and then download a CSV file of all of the existing users. And then you can kind of massage that data. You can extract, username with the CSV, or you can play around with different kinds of AZCLI commands to extract that data. And I think that's probably what I ended up doing was some AZCLI commands to load my users.csv file. So these are going to be all of the headers of the CSV file. And then these are all required for every line. However, there's also a usage location header, which I'll show you. And this is required for your users that are assigned to Microsoft licenses, such as like Office 365 or something like that, which I did have a couple of users that had that, and I was getting an error when I tried to first implement this. So I just found I had to put that value in there for that user. So we'll go ahead and take a look at the CSV file quick, and we're done with the SPN stuff. So we'll take a look at this is the users.csv file. I just made up some usernames and departments, job titles, and then I put in their mail nicknames, and I gave them preferred language just randomly to experiment with a couple different ones. Like I've got English, I've also got Japan and France for some of the users. So there is a list that Microsoft has that gives you the acronyms for each country's preferred language. So I've filled out all of the data for this, but I didn't enter any usage location. I don't have any Microsoft licenses. Just note that, if you ran into an error, that could be why, because that happened to me. So let's see here. That is step 5, populate that data. Step 6, assign the users to a department, such as art or engineering. So as I showed, I assigned everybody either art or engineering departments. And this will allow you to see how we can auto assign the membership to Azure Active Directory groups in the lab. So the art group is going to use dynamic membership as a type setting in the Azure AD Terraform resource block. And that requires the Azure AD Premium P1 license. The art group also includes a conditional access policy assignment enforcing multi-factor authentication to log into the portal on all users that get assigned to that group. The other option is the engineering group resource block, which includes a for each argument, and that's going to loop through all of the users. And for each user assigned to the engineering department, it assigns their membership to the engineering group. And so this is a dynamic way of doing it, but it's not like Microsoft Azure's dynamic way of doing it in the resource block of the Azure AD group. This is like dynamically doing it through the code So if you do it in this way, then you don't have to purchase the Azure AD premium licenses, which is a nice way of automating your group membership and also keeping your costs down, especially if you don't require the use of conditional access policies. Say you've only got like 30 to 50 users that you're managing, you can pretty much script that out like using this method, which is what I've done in my production environment. So I can just reference this real quick. So here we've got our engineering department users, and then here we've got our art department users. So the next thing we'll be looking at is this users.tf file, because this is where the actual for each meta argument loops are set. So we've got our locals set here, and domain name is going to go in and grab my Azure AD domains, and it's going to assign the custom domain that I have for my Azure environment, which is jennasrunbooks.com. And what this is going to do is it's going to assign my mail nickname that's applied to all of my users, which is this column here, mail nickname. So it's like the first name and the last name, and then it's going to give them at the domain name, so at jennasrunbooks.com. And then the other locals value we have is for the users. This is a function. The CSV decode is a function that allows us to reference the values in the users.csv file throughout the rest of the config. So every time it loops over a new user, it's able to reference these users loaded in the CSV file. So the next stanza here, this resource block for Azure AD user, this is where the bulk of what we want happens. So what it's going to do is I added a couple notes here to kind of help explain, but the HashiCorp document goes into quite depth if you'd like to look at that too. I do reference that in my runbook, but it will loop through the entire list of users in the block mapped to each line of the users.csv file. And so what it's going to do is it defines each user key by their unique mail nickname. I did change this. In the HashiCorp example, they used first name because I was like, oh, the possibility of duplicates is rather high versus a mail nickname, you know, a first and a last name together. It's relatively low. I mean, that is how we have our identifiers for the Terraform state assigned. And then within that, we have the user principal name formatted to pull the mail nickname, and then that's the first value. So it brings the string to lowercase using the mail nickname in the front, and then at the at symbol, and then the domain name, which gets set here in the locals block, which is in my example is going to be at jennasrunbooks.com. The next section here is where the new user will be created, or even if it's an existing user. So I had to have all of my existing users actually log in with this new password that gets auto-generated against each user, and they had to reset their passwords with this new password. So it wasn't too inconvenient. I mean, people were able to easily understand, you know, exactly what the format was for the pattern. I had no issues with that. So hopefully users don't find that inconvenient, but as long as you provide good instructions, I think it goes pretty smoothly, and it's just worth the automation of this, because whenever you have new users join, you run the same procedure and you can just copy and paste, this is what your password's going to be, or have like a run book available to them. And they'll be able to log in for the first time and then reset the password to what they want. So I found it really efficient that way. So basically, this password stanza is going to create a last name plus a first letter of the first name, the numerical value for the length of your first name, and then the final values being exclamation 123. I added 123 onto HashiCorp's example because I found that I did have some users that had, what was it? Yeah, last names with like less than 5 characters. And so that really shrunk the length of their password and it didn't meet the Microsoft requirements. So then I had to manually reset the password. So if you run into an issue like that where you get an error in Terraform, it's still going to create the user, but you have to go into the portal and just manually do a password reset for them and then hand the new user the new password and then they log in and do their initial password reset. So this enforces the password reset and yeah, and then the rest of these values we already talked about are in the CSV file. So it loops through all of those and it assigns those values to the user ID. So I've got this all prepared to go here for a Terraform apply. So let's go ahead and just generate this. It is relatively quick. I paused the video to let this load. So we can see all of the new resources get created here. A lot of the resources came from the previous exercise or the previous runbook, like the policy here, the art group, and even the engineering group, and readers. We have readers across the entire subscription. So anyone who has Jenna's runbooks in their principal name. But here we get to the actual membership of our new users from our CSV file. So we can see that's working and we can see the new users being created here and that they are assigned their mail nickname at the custom domain name. So we'll go ahead and hit yes, let those create. And while those are creating, I should say that before we would run, a Terraform apply, we'd want to have everything all ready to go, which I had in this lab. But I'm just going to back up here and go back to this, my PR here. So what I would hypothetically do in a production environment, what I do right now is I get everything ready with like adding the new user. And then I push out my commits first and I create my PR so that my GitHub Actions workflow, which we have integrated with our service principal, automatically runs the GitHub Actions bot, which kicks out the Terraform plan so that whoever is reviewing my PR would be able to analyze quickly like what I'm doing here. Oh, you're creating a lot of new stuff. You're creating new conditional policies, AD groups, etc. Okay, we're creating stuff. We're not destroying things. And like I said earlier, if it was actually destroying or deleting resources, it would highlight as red. So they can go through this and review before I would hit apply. But we'll go ahead and go back to see the creation. Okay, so everything was created. Go through the validation section and just validate, first thing I would want to see is what does my Terraform state look like with these new users? And you can kind of tell based on the apply output here, but you can see how the users get created in this way. This is like their ID. So if you had to manually assign a user to a particular group membership, you would grab this ID for them and you would list it under the members section for that group. So that's why it's really nice to do it in a dynamic way, whether it's through the premium license or the for each, meta argument loop. Either one I think is a really nice way to do it, but you only have so many fields available for you to parse through in the CSV file. So you could do, we've already done department with engineering and art, but maybe you have groups based on job title. You could get a little more granular that way. that's an idea. Otherwise, you're kind of stuck with, doing it in a more manual membership way like this. The next thing we can take a look at is the specific settings for one of the users. So I just picked user A rows. So we can just see all of the fields that are available to configure for user A rows. Another item we can look at is an AZ CLI command to target against our infrastructure to list out all of the users that were created. So we're just going to double check that this is accurate. And I'm just going to remove my user accounts from this so we can just see what was created for the exercise here. And we can just see all of our users are created. We can also take a look at our groups, validate that our groups were created. So I'm just checking engineering was created. You can check, art as well. And then we can list the users of that group. So all of the users in engineering. And then you can double check what you have set in the CSV file. So user G, Marigold, engineering. So that about wraps it up for this exercise. And now you have a much more efficient method for managing Azure Active Directory users using the CSV file and a Terraform for each meta argument. Azure Active Directory group membership is dynamically configured using for each meta arguments against department names, which excludes the requirement for purchasing the AD Premium P1 licenses. So in this example, that was in the engineering group. The service principal used by the GitHub Actions workflow is further locked down to adhere to the principle of least privileges, and it's also configured in the Terraform code. And having your AD users groups and service principals configured as code, it allows for consistency of settings and permissions across your infrastructure. And then it also increases the level of security awareness since PRs are reviewed by your colleagues, and it's also a paper trail of the changes for code changes. So I hope this was helpful. If you found the demo useful, please be sure to like, share, and subscribe. I'd really appreciate it, and I look forward to my next demo with you here on Jenna's Runbooks.